Word problems. All right, try this one. Remember, when you're looking for volume, the key is formulas length, width, and height. So get those set up first.
And the number's 5.
They're X's. Those are all X's. There's no actual numbers on the figure. They're all X's. All right. So we have volume equals length, width, and height. So I needed my length, my width, and my height. So the way this one was set up, the length and the width were both X. So then we just needed to figure out the height. So it says the perimeter was 14. So that means I have 14 all the way around. So I have 8 X's that I'm going to take away from that. So it's 14 minus the 8X divided by 2. Because I have the heights. There's 2 heights. Because there's 4 X's on one side, there's 4 X's on the other side. So if you look at this, you have the X there, the X there, the X there, the X there, and we can call that, so we'll call that height. That's H. So I have 2H plus 8X equals 14, basically. What I would have. So 2H equals 14 minus 8X. So H ends up equaling 7 minus to 4X if you divide everything by 2. So I have X, X, and 7 minus 4X. And this question asked for What's the X value that's going to give you the maximum volume? So go to Desmos. So we graph it, and the peak is going to be my maximum value. So in this case, it's 1.17. So X equals 1.17. So then if you wanted to find out the volume, your maximum volume is 3.18. Which actually, if I thought of that before, it's the Y value there. So you already had it anyway. Yeah. So it's 3.18. So the key with all these is literally just coming up with your length through width. All right. Today we're going to start looking at rational functions. What makes a rational function? No. So negatives in numbers, a negative makes it an integer, not necessarily a whole number. But a rational function is something different. What makes a rational function different than a polynomial? Yes. Rational numbers are fractions. Rational functions are fractions. So they just have division in them. So the first thing we're going to look at is we want to find domain for these functions. Now, for those that like to use graphing calculators, I'll show you something. So if we were to graph these, so first one, this is what you end up getting. It's basically a straight line. So you guys say, okay, well, then that means my domain is all real numbers. This one, well, it has an asymptote at -6, approximately. So yeah, it has an asymptote at -6. So we're going to say my domain is everything except for -6, right? But it's also undefined at 6. So I have to eliminate that one too. So sometimes when you're graphing things, you don't necessarily see every possible domain restriction that's going to be in place. So graphing them is okay. It can give you an idea, but knowing how to do them out algebraically is also very important. The nice thing is when we're looking at domain, we're just looking at the restrictions. So remember, there's 3 types of restrictions. Can't divide by 0. We can't have a negative root, even root. And then we have those real life restrictions. For example, the actually, this was a really good example. It's the one we just did. Go back to that one. So So here was our volume problem, right? I know. So here's my volume problem that we just did. Is that graph an accurate representation of my volume? No, because all those numbers won't work. So when we're looking at it, my only numbers that are going to work are between 0 and when my x's use up all my perimeter. So that's 14 divided by 8. So I actually have a domain restriction for this one. And that would be my domain restriction. So even though this one, technically it's a polynomial with a domain is all real numbers, since it was a real life problem, there are restrictions built into that. So my domain would be from 0 to 7/4 in this situation. And that would be the part of the problem that I would have. So when you're looking at domain restrictions, sometimes we need to look at that as well. It's one of the domain restrictions that's very rarely talked about, and actually is probably the most important one that's going to come up most often. Is if not, you can get some really crazy answers when you're looking at some problems. So looking at this, we need to look at our domain restrictions. These ones are pretty simple. They're rational functions. So we're looking at dividing by 0. So in this first one, we have the x squared plus 64 equals 0. Or it does not equal 0, technically. So I have x squared does not equal negative 64. Now, if I did the square root of that, can that ever exist? No. So this one actually is all real numbers. I think Alex wants you to do this in interval notation. It does. So you'd write this as negative infinity to infinity. That's how you'd write the domain for this one. If you've never seen that symbol before, that just means all real numbers. Next one, same concept. I'm going to do x squared minus 36 does not equal 0. So x squared does not equal 36. Square root, this one I can do. So x does not equal, and remember when I take the square root of a number, we have the plus and minus version of that one. So it's plus or minus 6. If the square root is in the problem already, when you take the square root of that, you only have to do whatever symbol it tells you. Okay? So if the problem was y equals the square root of x, and I'm telling you x is 25, y is 5. Okay? Because the square root's already there, they're going to tell you the symbol they want, either a plus or a minus. In this one, I'm putting the square root in place. I'm using the square root to get rid of something, therefore I need both values. Okay. All right, so now we're going to write this one. Again, we have to write this in interval notation. So it's negative infinity to negative 6. Union, negative 6 to 6. Union, 6 to infinity. That's how you'd write that in interval notation. Don't forget the negative 6 to 6. It's very easy to forget that. Just go, oh, it's negative infinity to negative 6 and 6 to infinity. There's something in between those two that work. So, any questions with that? Remember, infinities, there are no brackets on those, so they're always parentheses. If we're including the number in this situation, we're dividing, so we're typically not including the number. All right. Yeah, let's look at horizontal and vertical asymptotes. All right, so vertical asymptotes are typically what? How do I find my vertical asymptotes? That's horizontal. Yeah, it's the zeros of the denominator. So it's basically my domain restrictions. The only time that it's not going to be a vertical asymptote is if I can cancel it out and it'll be a hole. So but typically you just look at the denominators and that's going to give you your vertical asymptote. So in this case, I'm just going to set the denominator equal to 0. So 2x equals 9, negative 9, x equals negative 9 over 2. So that would be my vertical asymptote. So for vertical asymptotes, again, just set the denominator equal to 0 and solve. This one's pretty straightforward and simple. Horizontal asymptotes, which we haven't really talked much about, is when we have to look at the degrees. So if the degree denominator, so actually we're just going to do it this way because I don't feel like writing this out. Is D and numerator is N. And those are the degrees. Okay, so if D is greater than N, my horizontal asymptote is Y equals 0. If N is greater than D, we have no horizontal asymptote. If N equals D, my horizontal asymptote is the leading coefficient of N over the leading coefficient of D. So in this problem, what's my horizontal asymptote? It's 0. The degree on the top is 0, right? There's no x. Degree on the bottom is 1. So it is. So 1 is greater than 0. So therefore, the horizontal asymptote is y equals 0. Remember, if there's no x, my degree is 0. And if there's no degree listed on a variable, then it's 1. So in this case, it's 0 over 1. So that would be 0. You can graph these. I would suggest graphing them on a calculator so you can see and verify your answers. So you can see here, there's my initial graph, horizontal and vertical asymptotes both make sense. Okay. So get the answer algebraically, find the things, use Desmos to check your work, and then put it in Alex. Okay. In this problem, they just wanted you actually to graph the horizontal and vertical asymptotes. So for vertical asymptote, so when you're going to do this, because it's really hard to get 9 over 2, plot the point. So 0 or negative 9 over 2, 0. So plot that point, and then you can put your vertical asymptote right through it. And then my horizontal asymptote was at. It actually removes it automatically for you when you put it there. So if you can see what I did, watch when I clicked the vertical asymptote, when I put it on that point, the point disappeared. And then my horizontal asymptote was there. All right, find me my horizontal and vertical asymptote for this one. All right, so vertical asymptote should have been 5/2. And my horizontal asymptote is 0. Okay. All right. All right, try this one. So in this case, my vertical asymptote, again, just set the denominator equal to 0. So x equals -3. And this one, my horizontal asymptote is not 0. My degrees are the same. I have a degree of 1 on the top and a degree of 1 on the bottom. So I divide the leading coefficient. So my horizontal asymptote is -1.
Uh,
3 divided by -3. Oh, okay. All right. So there is, so in this one was pretty simple. You want to look and make sure when you're looking at your vertical asymptotes that it couldn't cancel it out. Because if it cancels out, it's not a vertical asymptote, it's a hole. So in this case, you cannot do that. I don't know, because they're not asking for holes, so I'm not sure if they're going to actually have one with holes in this one or not. But it is a possibility. So things to keep in mind. Okay, there are topics with holes on it. We're going to go into those. All right, so now this one, they're both polynomials, right? Or they're both quadratics. So the first thing you're going to want to do is factor everything. And then we can worry about finding our zeros. Because the first thing I have to do to the bottom is to factor it anyway to find my zeros. So less factor. So I can pull out the negative sign in the bottom so I don't have to necessarily worry about that. So I'm looking for two numbers that multiply to 2 and add to 3. So that's 2 and 1. So in this case, my cannot equal -2, and x cannot equal -1. Now, if we took the top, looking for two numbers that multiply to -4 and add to +3, so that's x plus 4 and x minus 1. So neither of those can cancel each other out. So I have two vertical asymptotes. X equals -2 and x equals -1. The negative sign in front does not do anything to it because it does not have an x. So it's just like if there was a 2 in front of it or a 3 in front of it, it wouldn't make a difference in that respect. So I have two vertical asymptotes of this problem. Now my horizontal asymptote, what's my degree of the top? The degree of the top is 2. The degree of the bottom is 2. Remember, degree is just the highest exponent. Okay. So you're just looking at the highest exponent. So they're both 2 in this case. And I have 1 over -1, which is -1. So my horizontal asymptote is -1. So when you graph this one on Alex, you have two vertical asymptotes and the one horizontal asymptote. I don't think so. No, they don't have you doing slight asymptotes. Well, slant asymptotes are nice. They're not insanely important in terms of calculus. So your horizontal asymptotes, your vertical asymptotes have domain restrictions and those things that really do come into play when you're looking at how a function acts over time. A slant asymptote is just going to infinity. So we don't really need to know that it's changing at that rate over time. We have different ways to figure it out at that point. All right, so the only difference between this problem and the ones we just did was this problem asks you to graph the function, not necessarily find your horizontal and vertical asymptotes. We do need to find our horizontal and vertical asymptotes to do the problem, but we have to do a little extra work after that point to actually graph it. So what Alex wants is it wants the horizontal and vertical asymptotes and then 2 points on each part of the graph. Okay, so that means basically 2 points on either side of any horizontal asymptote. So if I have one horizontal asymptote, I need 2 points on one side, 2 points on the other side. If I have 3, or if I have 2 horizontal asymptotes like the last problem, I'd want 2 in the middle, and then 2 on the other side. So you always want 2 in each section of the domain, basically. So first thing I got to find is my vertical asymptote. So we'll start there. So -x plus 2 equals 0. So x equals 2. So that is my vertical asymptote. Once I found my vertical asymptote, we only have one. So what I do is I'll make a table. I will put that in the middle because I know I need. Oh, I've been writing and I didn't switch over. There you go. I'll make a table. I will put the vertical asymptote in the middle and just put an X there so I know I don't have any values of that one. I need 2 on either side of it. It doesn't make a difference which numbers you pick. Since we're going to do it out algebraically anyway, pick numbers and just going to plug them in. So I'm just going to do 0, 1, 3, and 4. Okay, because we're going to graph it with the plot point. So even if it comes out to be a fraction, it's fine. If you're trying to come up with numbers that are going to come out to be whole numbers and things like that, it's just going to make your life a heck of a lot harder to deal with. So if I plug in 0, so I have, and I don't even need to reduce these. The top is going to be -1 over 2. Because I have -1 over 2. Plug in 1, 2 minus 1 is 1. -1 plus 2 is 1. That's 1 over 1. So yeah, it's 1. Notice I'm not even going to reduce it because when I plug it into the points, you don't have to reduce it when you put it in the plot tool. So it's one less thing that you might mess up. 3. So 6 minus 1 is 5. -3 plus 2 is -1. 4. 8 minus 1 is 7. -4 plus 2 is -2. And now I need my horizontal asymptote. What's the degree at the top? 1. What's the degree at the bottom? So my horizontal asymptote is 2 over -1. Or -2. All right. Any questions how I found any of that information? You are more than welcome. Not calculator scientific. I'll show you. I'll switch over one. Finish writing it. So remember, you are more than welcome to use the Desmos Scientific Calculator. Just type your function in like that. And we did 0. I gotta put x equals 0. And if you click there, it'll give it to you as a fraction. So it's -1/2. 1. 2 tells you it's undefined, which it should be because that's your vertical asymptote. 3 is -5. 4 is -7 over 2. So notice how I just typed the equation at once and just change that one number and I get all my values. Okay. You also can use the Desmos Scientific or graphing calculator for this as well. What I would not do is I would not sit here and try to find points like this. Okay. What you can do is if you click this little gear right here, you can change it to a table. Here's the table. And you can plot your points in. So 0, 1, 2, 3, 4. Now, it's not going to give it to you as a decimal. It's going to give, it's not going to give it to you as a fraction. It's going to give it to you as a decimal. As long as it doesn't keep going on forever, you're fine. If it repeats, then you got to kind of find the fraction for it. But it'll at least will give you kind of the values and stuff like that. You can go from there. And worst case, what's 0.5? It's 5/10, right? I can literally write it as 5 over 10. So, but if it comes out to be a crazy decimal afterwards, just plug it into the scientific calculator and get the exact answer. Just plug the numbers in yourself. So you can use these tools to help you find your answers. You do not have to do them all completely by hand. Okay. All right. So now let's go to Desmos because now we've got our answers. Not Desmos, Alex. So my vertical asymptote was 2. My horizontal asymptote was -1. Oh, -2. Okay. And then we're going to plot my points. So it was 0 and it was negative 1/2, right? Or was it 1/2? Negative. Okay. 1 was 1. And 3 was, and then 4 was negative 9/2, right? Oh, 7/2? Okay. All right. Now, once you plot your points, you're going to click graph a function. It's going to give you a nice graph. If it gives you something crazy, you messed up your points. Don't hit check. Okay? You should have a general idea because you would have graphed in Desmos to see what the graph looks like. You should have a general idea of what the graph's going to look like. If it doesn't match, fix your mistake before you hit check. Right? These answers you should not get wrong. Okay? Because you have to graph it there, and it's not going to give you a nice graph if you screwed something up. So, like I said, what was I said I was going to do 9/7. What I did before, 9/2. You can see real quick, that's not the way it's supposed to look. I screwed up. Oh, that's right. I did the 9 instead of the 7. So, like, those are the quick, easy ways to figure out if you screwed up. Okay? So, use the information it gives you to your advantage. All right. Let's skip that one for a second. Come back to that one. Back to that one. Okay. This one. Oh, we do have to do slant asymptotes. I lied. It does have slant asymptotes. Sorry. It's good practice for your long division. All right. So step 1, let's find our horizontal and vertical asymptotes if there are any.
My guess is there'll be slants on the test too.
Is it already on the test? No, this isn't the test practice. These are just, I'm doing every topic that's in the lesson. The test is already on Alex, so you can look. I actually don't remember which one of these topics I picked. So my vertical asymptote, I have x plus 3 equals 0, so x equals negative 3. Oh, I didn't switch back over. There we go. Sorry.
All right.
You should have noticed that I was switching back and forth as I was looking at different problems on there to see which. Sorry about that. 2 screens. All right. So my vertical asymptote in this case is negative 3. Now that you rewrote the problem down right. If I'm looking at the top doesn't factor. So there's no numbers that'll multiply to 2 and add to negative 5. So I know I can't factor the top, so I know that is a vertical asymptote and not a whole. Now, in this situation, my horizontal asymptote, I do not have a horizontal asymptote because my degree on top is 2, my degree on the bottom is 1. So there is no horizontal asymptote. The only time there is a slant asymptote is when the degree on the top is exactly 1 more than the degree on the bottom. So if the degree on top is 1 more than the degree on the bottom, you can have a slant asymptote. The nice thing is all the problems I just looked at The only ones that are slant asymptotes are when it's a linear equation on the bottom. Why is that nice? Because if it's a linear and I'm dividing, I can use what?
Synthetic.
I can use synthetic. I could always do long division. Even if it was a quadratic, I could do long division. But since it's a linear on the bottom, I can do synthetic division, which makes my life a lot easier. So I can take the -3 on the bottom, -1, -5, 2, -1, 3, -2, 6, 8. So my slant asymptote is y equals -x minus 2. So remember, this is just always one less. So it's -1x minus 2. The other thing that doing this helps is if for some reason you could have factored this out but you didn't catch it, that remainder would have come out to be a 0. Because if it was a 0, then I know my vertical asymptote is really not a vertical asymptote, it's a whole. Because I could actually factor that out at the top. All right, so this is problem number 8. Nope, 9. There we go. All right. This one was just asking me to graph the asymptote, so I didn't have to come up with my points. So I have a horizontal or vertical asymptote at -3. And my slant asymptote was -x minus 2. So put your point at -2, because that's your y-intercept. And then I'm going down 1 and over 1. Because my slope was -1. Your slant asymptote will always be in the format of a y equals mx plus b format. So it'll be nice and easy to graph. Graph your y-intercept. From there, just do your slope. All right. Find me my vertical asymptote and my slant asymptote for this one. And then we'll do our 5 points. Same problem, don't worry. So I have a vertical asymptote of 2, x equals 2. And since my degree on top is 2, my degree on the bottom is 1, There's no horizontal asymptote. In this instance, they're separated by 1. There's a slant asymptote. So we do our synthetic division on it. Notice this one out here is exactly what your vertical asymptote is. Okay, so saves you a little work there.
I forgot. 8 is the remainder.
Yes, so you do not use that one. Correct. Yep. Yeah, you never use the last number when synthetic division. It's always your remainder value when you're looking at things. Now I got to come up with 2 points on either side. So we'll do 0, 1, 2, 3, 4. So we've got 4, 2. So I go over to scientific calculator, plug in 0, I get -2. 1 gives me 5. 2 is undefined as it should be. 3 gives me -5. And 4 gives me 2. So it was what? 2, 5, -5, 2?
-2, 5. -5, 2.
Okay, thank you. So now we can go to our Alex and put those numbers in. So graph my vertical asymptote at 2. Horizontal asymptote was -6. And then down 3. And over 1. Was it positive 3 or -3? Oh, it's positive 3.
Yeah,
Okay.
it's +6.
So then I go down 6. And then up 3. And over 1. So then I plot my points. So 0, -2. 1, 5. 3, -5. And 4, 2. And graph my lines. The odds of you messing up your points and still getting a graph that looks correctly in here are slim. Yes.
I don't know if you noticed, but some of the lights went out.
Oh, because nobody's been walking in the hallways.
Oh,
They're on a motion sensor. So
no power outage.
no, otherwise this would have all gone off.
Good. So grab a bite in the canteen after class, but
Yeah.
power outage, there's
No.
not many good options.
What's really crazy is if it's at night and it's dark and then the lights go out, it's like, yeah, just nobody's walked down the hallway recently. So, yeah, the odds of you getting a graph that looks right here and you messed up something are slim. So if your graph looks right here, it's probably pretty correct. But again, I would check it in Desmos just to make sure. Yeah, we'll do this one first. All right. So now these two problems that the next two problems we're going to do adds in holes. So same concept, still find vertical asymptotes, horizontal asymptotes. I would start with that. The difference is your vertical asymptotes could also possibly be a hole. But again, we've been talking about that along, looking at factoring the tops as well. So 5x. So x plus 5 equals 0. So x equals -5. So that's either going to be a vertical asymptote or a hole in this case. So now we're going to look at our top. Oh, thank you. It's okay. I really like. there. We're going to show you. I'm going to show you that right now. So all I've done right now is we know that's a domain restriction. It could be a vertical asymptote or a hole. When we're looking at it being a hole, that means it's got to be a part of the top too. So we've got to factor the top. If you look at this one, 5x plus 25, I can pull out a 5 and I get x plus 5. So since I can cancel that out, that's a hole. Since I can cancel that value out of the problem, it's not going to give me a vertical asymptote, it's going to give me a hole. There's going to be a hole at -5, yes. 5, -5 actually in this case. So my g of x now actually in this case is just 5. Because I was able to cancel out the bottom. So this one is literally going to be a horizontal line at 5. So to graph this one, I have a hole at -5, 5. Okay. And then I can literally just put 2 points on either side of it. Why did it not? Weird. I know that's incorrect.
Maybe it's the back top point. To the left.
Did you do the horizontal one?
There isn't a horizontal asymptote in this case.
Is that point to the right? That's the 1 unit away instead of 2.
Well, that doesn't matter. They're all at 5 though. Problem is this is not drawing my line all the way across. Weird.
Did you draw the ass?
Oh, where it intersects.
Why do you graph it first then? A hole on it?
Maybe you want
Weird. Like, because it's only one. There's only one point. They just put in the. They just put in the asymptote. I don't know. There's a hole to graph. The hole's there. In addition to the hole, we need to plot one other point. They only wanted one other point in this game. It said 2. Maybe. Maybe. Yeah. I kind of want. All right, let's do this one. I actually kind of want another one of those. We'll try this one. Try one that does not actually have a crazy thing like that.
That's 3x minus 12.
Yep, 3x minus 12. All right, so in this one, we have a vertical asymptote at 1, because there is something still left in the denominator, and we have a whole at x equals 4. So my new problem that I can look at, so I don't have to necessarily look at the original one, which is fine, you don't have to. 3 over x minus 1, my horizontal asymptote for this one's going to be what? Yes, because my denominator is bigger than my numerator in terms of degree. So now I need 5 points. So we'll do -1, 0, 1, 2, and 4. Always make sure you use your whole. Okay, you have to make the whole one of them. All right. So this one's simple enough to just do out. So I've got 3 over -2, 3 over -1. That one doesn't work. 3 over 1, and 3 over 3. And remember, that's a whole. So why does the whole work?
Because it's not part of that problem that you did.
Right. I simplified the problem down. So the whole will work in this one. Okay. But it's a whole because it didn't work in the original problem. All right. So we've simplified our problem down, but the original domain restrictions still hold true.
Or would you simplify it with the x minus 4? Did you still have it?
So when I'm doing the work, I would have simplified it down to do the work, just like I did there. I wouldn't plug it back into the original problem. The other reason is we need to know what 4 is, because I need to put a hole in that spot. So I need to know where that point is. So there's no way to do that in the original problem. I had to do it in the simplified problem. So that's 1. That's that. All right. So I've got -1 was -3 over 2.
Yeah.
0 was 3.
3 over -4.
So -3. 2 was 3. And 4 was 1, right? All right. So I got my points. I need to change my 4 to a hollow to an open dot, and then we graph our line. So that was most likely the mistake on the previous one. I had too many points. Since there was no actual vertical asymptote, you only needed 2 points. You needed the whole and one other one. It still should have drawn the line. I don't know why it didn't. It shouldn't have stopped. There are a few topics in Alex that there's little things that it just does wrong, and it's a computer issue. All right. Find me all the information for this one. I know I'm writing. I'm leaving it on that screen on purpose. Minus 20. minutes over.
Oh.
You don't necessarily have. You just need two over here, two over here. Because you need two in each of the sections.
So
Just pick two of them before you choose between them.
so I can.
Yes. Yeah. So, and then, yeah, just do. Like, if you probably want those. It's different all. Yeah. Okay. So major thing, one before them. Yep, and then 2 points after. 2 points. All right, so most people got to the point where they factored it, and you got two vertical asymptotes. You had one at -4 and one at 5, and your horizontal asymptote was at 0. There are no holes in this problem. That can happen. Don't automatically assume there's a hole. Don't automatically assume there's a slant asymptote. Even if they give you the options for it to do it, doesn't mean it's going to happen. Okay, we just did one with holes, and it's like everybody's like, wait, there has to be a hole somewhere. There doesn't. There's two vertical asymptotes in this case. Now you got to come up with points. We need 2 points over here. So you need 2 points before -4. You need 2 points between -4 and 5. And you need 2 points after 5. I cannot have all 6 points in the middle. I need 2, 2, and 2. You can choose any numbers you want. All right, as long as it's going to fit on the graph. So the closer to the asymptotes, probably the better, but it doesn't make much difference. And remember, use the scientific calculator to help you. So this way you don't have to do the calculations over and over again. So use those things to help you figure things out.
Would you not want to factor the top?
Yeah, I factored the top. You have to factor the top just in case. So like in this case, when you factor the top, you get, actually I'm going to show this one now. You get 10 times x minus 2. It just doesn't cancel out. But that's the only way you know there's no hole. And I'll tell you, the first time when I'm looking at this, I'm like, I'm doing it out, I'm like, there's no hole. Oh, okay. Like, because we were doing ones with holes, and it's like all of a sudden now there's one that doesn't have it. That's possible. All right. So this one just happened to have two vertical asymptotes.
So when you do that, it doesn't change the degree of the bottom.
The degree, right? We didn't cancel anything out. So my degree on the bottom is still 2. My degree on the top is still 1. So it's still a vertical or horizontal asymptote of 0. And if you canceled something out, then my degree would change, but they would both change evenly. So typically, your horizontal asymptote is not going to change when you cancel something out because you're canceling one from both of them. So I chose -6, -5, 0, 1, and then 6 and 7. Those are the numbers I chose. But again, it doesn't necessarily matter which points you choose. You just have to make sure you choose points that work in each section. And you have to pick points that will show up on the graph. Oh, actually, I lied. This one only wanted 1 point in each section. And it says, so plot the intercepts. And plot at least 1 point on each side of the vertical asymptote. So I only need one. Oh, shoot, that's what's graph. I have the point in each. All right. Alex wants to be picky. So when you click your graph tool, if you didn't put points in these regions, it yells at you. So you have to pick numbers, right? Yeah. Yeah. So it wants -5, -3, 4, and 6. -5. Yes, it is annoying actually. Huh? Yeah, it's just right. It's just this plot 1 point each side of the asymptote. It's like, okay, that's fine. It's not like, but the good thing is it didn't mark me wrong. I know it marked me wrong because I hit it after I did something. But when you click the graph tool, it would have told you that immediately. It didn't mark it wrong once you did that. So it does kind of give you that hint of where it is. I just didn't understand what it actually meant by that. I'm like, okay, I did points to each side. It actually wants them in the shaded regions. So, which is highly annoying. 25/4. The good thing is you're going to be doing this out by hand on your paper, so you wouldn't necessarily have to hit the exact points like this. Four. I didn't. I actually took them right from Alex, so I don't know. You already have the test. I'm literally taking the test that's in Alex right now. It gives me 5 copies of that test that I can print out. I just printed one.
If you do all of them, you probably know your stuff.
If you do it a bunch, you're going to probably have seen every question that's going to show up on that test.
You print out the Alex test?
You can't. I can't.
You can't?
No.
Oh.
All right.
The index card.
Yeah.
There we go. So it's 10 questions. It's there. You can go through and see all the 10 questions. They're going to be in the same order as they're on the things. The numbers are just going to be there.
Just for a refresher, the review test, does that affect your grade
No.
or just the actual test?
Just the actual test. Oh. And it wants the intercept, which is at 0.2. It also apparently wants the y-intercept. Jeez.
What else does it want from you?
Where's the line?
One.
Oh, I see it. I see it. Yeah. Sorry.
The nice thing is once you graph it, you could just click those because you didn't need it to graph those. All right. Away from the annoying those graphing problems. Let's do other annoying graphing problems. All right. This one, okay. I'm going to give you the easiest way in the world to do this one. Just graph it in Alex and pick the graph that matches. Okay? In all honesty, this is literally this topic. Just graph them in Desmos and see which one matches. The thing about them, though, is like you'll notice each graph has something slightly different about it that you'll easily see. Like graph A and B look very similar. The only difference is their horizontal asymptote is different. Okay. Graph, actually, like this one, the vertical asymptotes are closer. E and B or E and C, the middle piece is in a different spot. Like they've completely flipped each other. So you should be able to look at the one in Desmos and say, okay, it's got to match this one.
We still need to find our vertical and.
You can do it from Desmos because they're giving you the graphs. You're just going to graph it and match them. Yeah.
Wow.
This one's going to be literally that simple. Yes.
Can you use Desmos during the test?
Yes. If you have it on your phone, you can use Desmos on your test or your tablet. That's fine. So there's 2 apps. So you can either download the apps or you can just go to the website. It'll work the same way. So, but as I said, if I see anything other than Desmos, I'm going to make everybody go buy graphing calculators. And nobody's going to want to do that. So, all right. So here's the first graph. Looks like my vertical asymptotes are around -4 and 3-ish. And my horizontal asymptotes in the middle. So we go back to the graph. Horizontal asymptotes in the middle. So it's either B or F. -4 and 3. So it's got to be B.
Alex, let you copy and paste the number.
What do you? Oh,
Like copy it.
No, I tried.
no. Because it's actually an image. It's not that hard to type it in.
Yeah, but that's like 15 seconds.
Oh, darn. All right. This one, my loop's down the bottom, and there's only 2 that had the loop. So that's got to be E. So for this one, you can just straight up use Desmos for it. All right. This is one of those topics that looks extremely difficult. Okay? It's not. It just looks that way. So when you're looking at this problem, they've given us all the different possible formats of it, and we're plugging in numbers for them. So the first thing is it has 2 vertical asymptotes. Okay? So that means my denominator has to have 2 parentheses in it, correct? So that means it's either going to be one of the last 3s. I can eliminate the first 2 right off the bat. Okay? I know it's going to be one of the last 3. My horizontal asymptote is 0. Well, that means that my denominator, my degree on the bottom has to be bigger than the top, correct? So that means it can't be this one. So that means it's got to be one of these 2. It doesn't have an x-intercept. And it passes through 2, 1. So if you notice, so actually just do one up real quick. All right. So this one doesn't have an x-intercept, correct? Doesn't cross the x-axis. Because the horizontal asymptote is 0, so it never actually touches there. This one does. What's the difference between the 2? Where is the x-intercept on this one? It's at 2. Look at my equation. Where would that 2 come from? The numerator. It's going to make the numerator 0. Okay? Which would give me my x-intercept, right? If the top's 0. So what's different between these two functions right here? This one's got an x variable in the numerator, right? And this one doesn't. So it's stated that there is no x-intercept. So if there's no x-intercept, I cannot have an x value in the numerator. So that means it's got to be that one. If I did have an x-intercept, that would have been my numerator. Okay? So I know it's this one. So I know my denominator is then x minus 3 and x plus 5. But I don't know what that is. So I have to find that. All right, let's switch back over to this because I got it right. So they gave me a point is 2, -1. And then I know my equation is a over x minus 3, x plus 5. It's too much like a 9. So we've got this. They gave me a point, so I can plug it in and find a. So I've got -1 equals a over 2 minus 3 and 2 plus 5. So a over -1 times 7, a over -7. So -1 equals a over -7. So that means 7 equals. So my equation is 7 over x minus 3, x plus 5. And again, don't just assume you're right. Check your work. So we can go back to Desmos. I got a vertical asymptote at -5. I got a vertical asymptote at 3. It does not cross the x-intercept. And I had a point, what was it, -2 or 2, -1, right? And 2, -1 is one of the points. So that's my answer. So it's really using the things that you know about it to work out the problem. So let's look at the first one here. When would this be true? Oh, I didn't check over. When would this part be true? I have one vertical asymptote and no x-intercepts. Say one vertical asymptote, no x-intercepts. Here, one vertical asymptote, an x-intercept. Two vertical asymptotes, no x-intercept. Two vertical asymptotes, one x-intercept. Two vertical asymptotes, two x-intercepts. Okay? And then you plug the point they gave you in to find A. All right, write me an equation for this. All right, I just needed to see one thing on the graph that they had. All right, how many vertical asymptotes? Two. So that means one of the bottom threes. How many x-intercepts? Two. That means it's the
Middle one.
last one because I have two x's.
If you fold that out, you got like squares, that's wrong.
Yes. In this situation, yes. Oh, I gotta pick this first. So I've got x minus 3, x plus 1. And then I've got on the bottom x minus 1 and x plus 5. And it tells me I have a horizontal asymptote at 2. So right now, the degree of my numerator and denominator are what?
One thing.
They're the same, right? They're both 2. No, they're both 2. The top is degree of 2 because if you fold it out, you get x squared. Bottom is also x squared. So my degrees are equal. So that means my horizontal asymptote is the top divided by the bottom, right? I can only put a number up on top. So what number am I putting up on top? 2. That's the only way it works. You don't even have to calculate out the a in this situation. Yes. On the bottom? Oh, it's x minus 5, actually. All right. So it's -3, +1, -1, -5. There you go. So yeah, this one you didn't even have to actually use the point because the horizontal asymptote gave it to you. All right. Any questions?
Wrong.
You can't they want this factored out. You can't FOIL this one out. All right. Before you run away, don't run away yet. I'm going to make sure everybody sees where this is. So just make sure everybody knows where this is. Your practice test under assignments, chapter 4 test review. When you start it, here's your 10 questions. You can jump around. Every question's got the explanation, an example, so you can use that to help yourself out. Okay, it's all there. Okay.
When do you post your video?
It depends. Sometimes it's right after class as soon as I get in. Sometimes it's first thing tomorrow morning.
Okay.
It literally just depends on if I get a chance to do it between classes today. So
I guess I'm missing Thursday, so I want to be able to.
it's there already. Yeah, last Thursday's is there.
No, I mean this Thursday.
Oh, this Thursday. Yeah. So it's if it's not there midday, it'll be there on Friday morning.
On Friday. Okay, that's fine.
All right, I'll.
Have a good night.
Thursday.
Thank you.
You too.
Thank you.
You're welcome.